Welcome to the introduction of Penn State Fayette EET 114, 118. My name is Ron Kalin. I'm an adjunct instructor. This is my contact information. A little bit about me. I have a BSEE, took some master's classes. I have a professional engineer's license that's active in Pennsylvania. I have 27 plus years experience as an engineer, electrical and mechanical. I currently work for Siemens Energy, and what I do at Siemens Energy, I work on turbine and generator specialty services for large power plants and industrial plants, and we do uprates and repairs around the world for turbines and generators. We have forced and planned outages. Some outages may be planned out for years ahead of time, and some may get dropped in my lap and have to be worked on immediately for tomorrow. I support Siemens, Westinghouse, and all its Chalmers units. I support competitors' units also, like GE and Mitsubishi Heavy Industries. My past employers were Mitsubishi Electric, Consolidated Container Company, and Elwood City Forge. At Mitsubishi Electric, I did large-scale video boards like the kind you would see in stadiums. I had the largest video board in the world. Was my first project, high definition. And then when I worked for Consolidated Container Company, I was a maintenance manager and project engineer, and we basically made plastic containers like the kind that you would have in your fridge, half gallon, gallon, and quarts, etc. of a few different types of plastic. And then at Elwood City Forge, I was a project engineer, mainly deal with electrical systems, but I also did a lot of mechanical design and process changes and things like that. And then prior to that, I did a co-op program with ECF, which I highly recommend if you get the chance to do that. So on to the course syllabus for EET 114. This is Electrical Circuits 2. So it's going to be the AC side of the circuits that we did in EET 105. This semester is going to be web-based course asynchronous, which means that we don't have a specific meeting location and time for this course. Again, here's my contact information and my office hours. I would just text me if you have a quick question about homework or anything else related to the course. You can just shoot me a text. That's the best way to get a hold of me. Uh, so this is a 4-credit course. It's related to direct and alternating current circuits analysis, including Thevenin and Norton theorems, mesh analysis, nodal analysis, capacitance, inductance, resonance, power, and polyphase circuits. Prerequisites are EET 101 or 105 and Math 81. So this is going to be a heavily into math. You need to use a calculator, and we're going to get into complex numbers. And also, again, the meeting information. So no classroom or time slot is assigned. Most of the assignments will be taught by YouTube or Zoom video. Each week there will be an update given via email with homework assigned from the textbook, and class sessions will be to watch the videos. The videos are typically way shorter in total than a classroom session would be, so it's actually more time efficient to do it this way. Labs will be given most weeks, but not every week, and that'll be for 118. Quizzes will be given on Canvas, again, not every week. Exams will be given in person during lab class. Email, text, or phone me for any questions. The syllabus is subject to change. If I make a change, I'll let you know, but I don't think I will make a change in the near future. Prerequisites and requirements. So you need the textbook. It's Introductory Circuit Analysis, Robert Boylestad, Here's the ISBN number. So you're going to need that. We're going to continue to the second half of that book in this course. You definitely need a calculator that can perform calculations on complex numbers. Examples: the TI-89 or the 36 or the 34. A calculator that can only do scientific calculations is not acceptable. So here's a picture of what the textbook cover looks like. I highly recommend that you have this textbook because during exams you will be able to use the textbook. If you decide not to get the textbook and use whatever's in Canvas, then you're not going to have that at your disposal unless you print out everything that was in the textbook for those chapters. Here's an example of the TI-89 titanium, and you can see some of the keys on it. This is very similar to the model that I have. I use the TI-89 still to this day. It's a very powerful calculator, and you don't have to get this particular one, but you do have to get one that can do complex number calculations. Also, you need access to an app that can do electrical circuit analysis. This is definitely required. I highly encourage every circuit. You could also use PSpice and Multisim. I believe there is in the lab in Eberly 309 or 310, I think it is. In the electrical lab, there are computers on there that have Multisim on it. Every circuit costs $15, but it's for life, and you can use it on the computer, on the phone, on the tablet, and it's very friendly. It's easy to use. I have a tutorial on how to use it, and I find it to be very powerful and useful. And you will need it whenever you're doing the labs online. And even in person, it helps reinforce the fundamentals and the principles behind each lab. On the next point, again, you need to have a good understanding of algebra and taking concurrently a trigonometry course or understand trigonometry fundamentals. Math 81 or its equivalent is a prerequisite. We're going to be doing DC and AC analysis through series parallel circuits as covered in EET 105, and some rudimentary computer literacy is helpful. Should be able to search the internet and use MS Office, Word, and Excel, especially Excel. I'm going to pretty much require you to use a little bit of Excel in the labs. So the goal is to have a completion of the circuit sequence of the material begun in 105. The student should have a firm grasp of AC and DC circuit analysis techniques. Many of the topics are given only cursory coverage in the previous course and are expanded in this course. The relationship to EET outcomes, we're going to contribute to an ability to apply knowledge, technique, and skills and modern tools of their disciplines to electrical engineering technology activities. So the performance indicators are going to be use analytical methods to solve electrical engineering problems, definition of capacitance and energy stored by a capacitor, AC-DC circuit analysis techniques, mesh and nodal, network theorems like superposition, Thevenin and Norton, and maximum power transfer, definition of the power triangle, watts, vars, and VA, and power factor correction, series and parallel resonance circuits and the quality factor, three-phase generator, delta and Y connected three-phase load, non-sinusoidal circuits, Fourier series and circuit response to non-sinusoidal inputs, and also to use trigonometry concepts, complex algebra, system equations, and phasors to find quantitative solutions to electrical circuit problems, including analysis and applied theorem. So the course topics are going to be as follows. We probably will maybe do a brief review of 105, go over these four chapters 8, 9, 10, 11, and 12 to go because that's laying the foundation for what we're going to expand on in this course. We're going to do source conversion, circuit theorems, maximum power transfer, network theorems, uh, capacitor, inductor theory, and then magnetic circuit theory. So then we're going to start off with this course with a new material. Chapter 13 is sinusoids. 14 through 17 is going to be touch on a lot of what these other chapters touched on, complex algebra, and then doing inductors and capacitors, sinusoidal response, series and parallel applications. And then chapter 18 is going to be method of analysis AC, which again was what chapter 8 was in the prior course. And then 19, same thing as chapter 9, network theorems. And then 20 is new, it's AC power. And then resonance, chapter 22, passive filters. Chapter 23, transformers. 24 is polyphase systems. 25, pulse waveforms and ERC response. And then chapter 26 is non-sinusoidal circuits. And then we're going to have some exams and quizzes and reviews in there. So each section has a certain amount of time to get them done in hours. We're going to have a special topic paper presentation weighted as below. So there will be one term paper, formal paper to be written. Every student has their own topic. We will publish all the topics. I do not want duplicate topics, so it's on a first come, first served basis. The safety topic in class, we will not do that for web asynchronous, but if we did do it, it would be just, go round robin in the class and each student takes a topic and talks about it at the beginning of class. This course is concurrent to EET 118, Circuit Lab 2. I will coordinate topics between 114 and 118. Course grading, there'll be 2 exams plus a final, each weighted at 23.33%, so 70% of the total. The term paper I mentioned before will be weighted at 10% of the total. Homework and quizzes each weighted at 10%, so 20% of the total for the 2 of those. Participation is always helpful. Asking questions. I wanted to do Aviva Engage, but I couldn't get everybody to be invited to have a collaboration on homework and labs, but obviously that is encouraged. Demeanor ethics violation will be minus half a grade or letter grade minimum up to an F, and the final grade is broken down as shown here. Attendance is 100% expected. The lower single score in each category, test, quiz, and homework, will be dropped at the instructor's discretion, and that would include the lab also for 118. The final exam and term paper will not be dropped. Extra credit will not be given. So attendance each class watching videos is expected and imperative to learn the material. Missed lessons require stated reason to make up work. Completing homework is essential to the learning process. Highest ethical behavior is expected at all times. Active participation is beneficial to all. Here's my contact information again. Going over to homework and lab report policy. Homeworks and labs will be completed using answer forms in Canvas, and each student's own handwork be submitted in Canvas or 0 grade will be given. Submittals to be single PDF files. I do not want a dozen photos sent me of every page in Canvas or by email. I want everything to be submitted by Canvas and in a single PDF. Late homeworks and labs 1 week's grace period will result in deducted grades and compounding deductions. Increasingly reduced credit will result for repeating offenses at the discretion of the instructor. So that means that I give you 1 week's grace, but I will deduct if you go into that 1 week. And if you go after the 1 week, I may allow you to enter something, but it's really going to be deducted. And I expect you not to continue this process. Please stay with the schedule. Try to work ahead if you can. It's to your benefit. Um, no extensions after closing date will be allowed. Online labs will be performed individually using an app like every circuit, and each student will submit their own work online in MS Excel form. No submittals accepted after 1 week late. All group assignments must have all team members on it, else the grade is 0. So please show all your work, put everybody's name on the assignment. I I don't want to give anybody a 0 grade, but if you don't show your work or you're not handing something in or you're not putting in any submittal, I may give you a 0 grade. Quiz exam policy, they'll be held during a session communicated by email. Quizzes are going to be done in Canvas. They'll be open book and notes, otherwise, unless otherwise noted, but I usually almost always do open book and notes. Calculators required. Phone and laptop or other device not allowed. Online quizzes or exams will be timed and required online answers to be completed in Canvas. Your own handwork must be posted in Canvas in a single PDF again immediately after time is up, or a 0 grade will be given. Makeup exams are allowed up to 1 calendar week from assignment date. No exceptions after 1 calendar week. Please plan ahead. If you cannot make and you're going to miss a date, let me know ahead of time. We can make arrangements ahead of time, or if you're going on a trip or you're sick or whatever it is, you can make arrangements with me, but I will not do it after 1 calendar week. We just have to keep moving forward in the class. So after 1 calendar week, a 0 will be given. Final exam, there'll be no late makeup allowed. If needed, early makeup arrangement must be made. All homework, labs, and quizzes and exams to follow the handwork expectations document. If handwork is not submitted for any assignment or problem, any and all answers given will be considered wild guesses and a 0 grade will be given. If handwork does not meet the minimum requirements of the handwork expectations document, deductions will be given up to and including 0 credit. What does that mean? Well, here's the handwork expectations document. So handwork must be legible, clear, and readable. Must not be too light or dark, too big or small. I have to be able to read it. Written or typed with black or blue or pencil colored writing font on white, blank, or lined paper or background. I prefer you to print out the quiz or exam and fill it out if I'm giving a quiz or an exam. I'm probably not going to give any exams online, but I might. Having the proper header at the top of each page, course number, assignment number, name, student name, date, page number, total number of pages. See the example. So I put what the course number is. This is going to be for 114. I put what the assignment is, what chapter it was on, what date that I did it, the page number, and the total number of pages, and then put my name. Your name is a must. I need to at least have the name, the course, and what the assignment is at a minimum. Each problem has to contain all parts of the problem, i.e. the problem number, which would be this part, the redrawn circuit, if it applies, and then the formula that you're going to use. which is shown here, and then the work shown in the formula, putting the numbers in, and then the answer, including the unit, put a box around it. Um, I like this kind of format. It's easy for me to understand, and it's easy for you to show me that you understand how to do the problem. If you just put the answer in there, I have no idea if you understood it, what you did to get to that answer. I have no idea. So I may just give you a 0. You can't just put uh, problem 20 and then put 2.70 amps and put a box around it. That's not acceptable. So anything less than the example above will have points deducted up to and including 0 credit for the problem, regardless of the correct answer is given. This obviously does not include most true false multiple choice, where it's just a single answer. Scan your handwork into a single PDF file and submit into Canvas as instructed. Do not send me emails of PDFs or photos. I use Adobe Scan. It was free on my phone. Here's an instruction link on how to get to it. This will be posted in Canvas. And then I have step by step on how to do it. I'm not going to go through all that, but once you do it one time, it's pretty intuitive, it's easy, and you can take multiple scans. You don't have to do one scan with one file. You can do a multiple page single scan with a single file. And then the reasons are obvious. You're demonstrating that you know the material. You're making an effort to show the work is coming from you. And you're also giving yourself a higher chance of getting the problem right. If you show me step by step on how you did it, um, you're less likely to make a mistake. And lastly, it allows for partial credit if the answer arrived at is wrong. If you have a math error or an algebraic error or any other error where you just probably copied the number down wrong, or a clerical error. If you put the formula in most problems, I'll give you at least half the credit for that particular problem. It has to be the right formula. You can't just write down every formula there is known to man. Um, you have to put down the correct formula for that particular part of the problem to get half of the credit for that part of the problem. Attendance is required. Again, this is going to be related to watching videos, and where in each video I go over the topic. I go over what I would go over in class, what I would write up in the board in class, and then I go over examples and the solution to that example in detail, how to get it done. And then obviously you need to know how to use Canvas. Hopefully at this point most of you are very familiar with it. You can use this URL to access Canvas, and then you log in and you pick your course and you can go through. And the next video will be to show you how to navigate my course in Canvas. Then the rest of this is just boilerplate information you could read on your own. It's just standard info that, in case you want to drop the course or you're having trouble, you need counseling, or you have a special situation. It goes through all the generalized boilerplate information for the course, and that'll be this syllabus will be posted in Canvas so you can go over it on your own time.